All right, here we're going to go over this algebraic proof. So with proofs, you are always given some information. It's like, if we know this, we're given this information, then prove that this is true. So in this case, they're giving us the fact that they're giving us a lot of information. And then they want us to prove this. So for this one, they're actually giving us a picture as well, which is nice. Let's look at what they're giving us in the picture just to get a better understanding of what we see here. So first off, they're giving us AB, which AB is this line segment from A to B. And if you look above, you see that from A to B is 6x minus 4. And they're telling us that here as well in our given. It's in the picture and then also written down there. And then they're telling us that if you add AB to BC, BC is from B to C, so the red plus the blue, and if you look above that line segment, you see from B to C, it's 3 minus 2x. They're saying that if you add those two together, that's going to equal AC. So from A all the way down to C. So the red plus the blue equals the pink, okay? Which is, the pink is 2x plus 1. So if they're telling us the red plus the blue equals the pink, and they're telling us what the red is 6x minus 4, the blue is 3 minus 2x, and the pink is 2x plus 1, they want us to use all that information to prove that x equals 1. So let's look at the proof. A proof is we're going to do a two-column proof. Their first column is always your statement, and then the next column is your reasons. You want the statement to ultimately be what you were trying to prove. We want to go through and end up with x equals 1. So how do we get from what they're telling us to x equals 1? So you always start with what they told us is true. It's given. So the reason we can say that is because it is given. Okay? Now think, how do we get from that to x equals 1? If you look at it, they're giving us an equation, which is good. We know how to solve equations, but there's no x's in that equation. But they're telling us that AC is 2x plus 1, so we can substitute that in and we have some x's. They're telling us BC is this, and they're telling us AB is this. So let's substitute all of those into that equation, and then we have some x's. So the reason we could substitute those values into that equation, AB plus BC equals AC, is because of the substitution property of equality. The reason we can go from what we wrote in statement number 1 to what we wrote in statement number 2 is because of the substitution property of equality. You have to justify the change. We went from this to this because of this. So now, remember, we're trying to get all the way down to x equals 1. Think about what's the next step? What would we do to get to x equals 1? Well, when I'm solving an equation, I look at each side of the equal sign and see if I can simplify anything. If I look at the left side, I see some like terms I can combine. Like the 6x minus the 2x, that's 4x. And that minus 4 plus 3, or plus 3 is minus 1. So I simplified that. This is the one kind of reason that you don't have to use one of the properties. You can just say that you simplify. Or some people will say combine like terms. They're not actually giving one of the properties. So now let's think, what would we do next to solve this and get down to whatever x equals? So when I have x's on both sides of the equal sign, I like to move them all over to one side. So I'm going to move that 2x over to the left side. Now, when you're solving these, you don't actually show your step like you would solve an equation. You don't say, okay, I'm going to subtract 2x here and subtract 2x here, and what's my answer? Okay? You can do that, but it doesn't actually go in the proof. When I subtract 2x from both sides, that ends up with just a 1 on the right side, and this 4x minus 2x is 2x. So my next statement is 2x minus 1 equals 1. So 2x minus 1 equals 1. I don't actually show that I subtracted 2x. I just change it. And then you have to say, why could I change it from 4x minus 1 equals 2x plus 1 to what I put in step 4, 2x minus 1 equals 1? Well, I subtracted, what did I do? I subtracted the same number from both sides of the equal sign. What property allows you to subtract the same number from both sides of the equal sign? That's the subtraction property of equality. That's why I could change it. I subtracted 2x from both sides because of the subtraction property of equality. Now if you think, well, what do I do now to get this down and figure out what x is? I'm going to start moving numbers away from x. So I'm going to move that minus 1 to the other side. Now for me, I see that as, okay, it is minus 1. I'm going to change it to plus 1, because when I do that, that cancels out. And that'll give me 2x equals 2. You could also think of it as subtracting negative 1. And that's what they did on the PLP classroom. They thought of it as subtracting negative 1. If you thought of it as adding 1 to both sides, then that's fine. That's what I see it as. You could also put addition property of equality if you thought of it as adding 1 to both sides. So we're almost there. We were able to change it to 2x equals 2 because the addition property of equality allows you to add the same number on both sides of the equal sign. That's what that property states. Now the last step to solve for x, I want to divide each side by 2. That's what I'm doing to see that finally I'm able to prove x equals 1. So why was I able to change it to x equals 1? Because the division property of equality allows you to divide both sides of the equal sign by the same number, okay? So this is a proof, you guys. This is what you are doing in this class for this unit. It's a big part of geometry, is going from one step to the next step, one statement to the next statement, but each kind of statement that you make, you need to justify why you're able to say that.